Hey there, I'm Floppy. Today we are going to derive the complex identity for cosine, but not with the algebraic way. Instead, we are going on a discovery trip to find the geometrical meaning of this mystical expression, and then explaining why it necessarily must equal to cosine of theta. For your audience, I expect you to at least know the Euler's formula. You don't have to know why it is true, but a complex number can be represented by its angle and the distance from the origin, which I will be representing as e to the I theta. For starters, it's enough to see it as a notation trick in order to follow the video. With that said, let's figure out the meaning behind our main dish. To start the geometrical derivation, we need to construct some things to work with. We begin with defining a complex number on the unit circle. The right part, a plus bi, tells us that z can be broken down into components a and b, forming a right triangle. The same complex number can also be represented as one unit away from the origin, rotated theta radians. Now, we have successfully defined a complex number geometrically, such that it matches with one of the terms in our mystical expression. The next step is to create a geometrical equivalent complex number, such that it matches with e to the negative I theta. To do so, we can see e to the negative I theta as e to the I times negative theta. Now, the negative theta has a property to rotate the complex number in the negative direction, and this will result in a new triangle congruent to the previous one. Notice that the magnitude of the angle and the height is preserved, but the orientation is negative. Our next step is to put them together to create what we got in the numerator. And really what we do is to add the components of the complex number, which is geometrically equivalent as moving the triangle such that the tip touching the origin is linked together with where e to the I theta is. The resulting point on the real axis is exactly where e to the I theta plus e to the negative I theta is located. And this specific coordinate is located at the distance equivalent as the sum of the width of the two triangles, which means that e to the I theta plus e to the negative I theta is equal to 2a. But what is a? Well, if we look at the blue triangle, we see that a over 1 is cosine theta, and that shows e to the I theta plus e to the negative I theta divided by 2 must necessarily equal to cosine of theta. Now, let's wrap up the video by watching an animation, which I think is representing the healthy way to see how the complex identity for cosine works. Using Desmos, we can see that the coordinate for e to I theta, e to the negative I theta, and the sum of the coordinate shown as the black dot. As we let theta varies for different angles, we can see that the triangles transforms, which results in new positions for the black dot, hence a point always located 2 times cosine theta away from the origin. Now we have come to the end of the video. Floppy seems to be happy, and I hope you also enjoyed the video. See you next time.